Hello, everybody. Hey, sorry, yesterday I messed up when we talked about week 5 worksheet help. I ended up not doing 5.4. Mr. Calicott and I kind of got messed up on our numbering. So if we look at, here are the answers to worksheet 5.4, which are ones that I didn't go over. And then motion number 9. It will be a future one that we will see later. Okay, so you guys, I'm going to do one of these problems. I'm going to do problem number 3 in an effort to help you with the quiz. Okay, so the quiz, which is 5.8, that was just put up today. Okay, it is going to have, you guys, it is going to have a bunch of questions, mostly on these types of problems, But there's going to be some easy questions on there that you want to take advantage of so that you can have more time to do the ones that are trickier. For example, in my lecture on acceleration, both acceleration 2 and acceleration 3, we talked about things like, what does it mean when it says rest? Okay, so it starts at rest or comes to rest. Well, that means 0, right? So that means 0 meters per second. So the velocity is equal to 0 meters per second. That's what rest means. Okay, now, if I ask you what G is, what does it mean to say G? Now, you guys, G is the acceleration due to gravity, and it is 9.8 meters per second squared. But we, in this class, are going to use 10. So that's going to be 10 meters per second squared. And that's the acceleration due to gravity that's going to go down. That is going to go down. Okay, so how do you know if you have something that is going to be under an acceleration of g? That's another way to say free fall. So if you have a drop, throw, kick, shoot, anything like that, if it's near the surface of the earth, it is going to accelerate downward at 9.8 meters per second. And we'll do an example here, number 3. But those simple kind of questions are also going to be on the quiz. Okay. Now we can get some other things, even going back to questions that, for example, I'm going to move this over here. So. All right, so now we got a little different part of the board. You guys, claim, evidence, and reasoning. If you go back there, so you're going to make a claim, you're going to provide evidence, and then you're going to give your reasoning as to why that works. You guys, this right here is basically the scientific method, okay? And if you are looking at the evidence that is most effective is going to be quantitative data. Quantitative has numbers, and numbers are better because you can compare them. Qualitative don't have numbers. It would be like the difference between it going from 75 degrees to 85 degrees versus going from warm to hot. What does warm to hot mean? So numbers are better. That is quantitative. Okay. Also remember Sultan. Okay. That is for graphs. And Mr. Calicott did a bunch of things this week on 4.5 and 5.1 and 2 where you're doing it. So scale, units, label, title, accuracy, and neatness. Now, when you do that, you guys, when you do that on the graph, when you do that on the computer, this accuracy and neatness is going to happen automatically, and you just have to plug those things in. So remember, we're going to have a graph here. One of those is going to be distance versus time. So remember, this one right here is the independent axis, and this vertical one is going to be the dependent axis. So, for example, time is going to go along no matter what we do. But if we move and we change our distance, then our distance will be dependent upon the time. And that's why there's dependent and independent variables. So along the horizontal is the independent and the vertical is going to be the distance. Even if that was a velocity versus time graph, okay, it's still independent and dependent, okay? So finally, let's look at question number 3 from 5.4, okay? And it says, you're looking for water. In a rock field, you find an old well with some rope and a pail, and you drop a stone down the well, and you hear the splash 2 seconds later. How long does the rope need to be to reach the bottom? Okay. So what do we know? So now we know from based on what I just said before that our acceleration is equal to g, okay, which is equal to 10 meters per second squared because it's going down. Okay. We also say that we drop it. We drop the bucket. So that means it's going to give us our initial velocity of 0. This VI and this VO, remember, that's the same thing, okay? The V final, you guys, we don't know, and we're going to get that after a second. So we want to know the displacement. How long does the rope need to be? How long does the rope need to be? That means displacement, okay? That time, it told us it was 2 seconds. All right, now you guys, if we look here, we are looking for displacement. We don't know the final velocity, so we're going to use equation number 3. You guys, this is the hardest part of these kinds of questions, is to figuring out which equation you're going to use, and that is going to take practice. But this right here is kind of giving you those clues. Now notice that we want this, and we have these other 3. And so for right now, we're going to ignore V final. And if we don't have V final, then we can just need 3 out of the 4 other variables, and we can solve for it. All right, so we're going to put in this displacement is equal to the initial velocity times time plus 1/2 AT squared. Okay, so this is what we're looking for. Our initial velocity is 0. So even though it's 2 seconds, it doesn't matter because 0 times 2 is still 0. Plus 1/2 of 10, that is our acceleration. And we have 2 seconds, and that gets squared. So 2 squared is 4 times 10 is 40 divided by 2 is equal to 20. Okay, so our displacement is equal to 20. So that means the length of our rope has to be 20. Okay, so now the other questions that are listed in there that you want to do is figure out what the average velocity is and the final velocity. And we're going to go back up to these equations right here to figure that out. So the average, okay, now there's a couple ways to do this, obviously, if we look up there, but the first one is we're going to do distance or displacement divided by time, which is 20 divided by 2, 20 meters, which is what we just got, and 2 seconds. 2 seconds is what we were given, okay? And 20 divided by 2, our average velocity is equal to 10 meters per second, okay? So the average is equal to 10 meters per second. And finally, what is our final velocity? What is our final velocity? And we also know, according to this, that v final plus v initial divided by 2 is equal to our average velocity. This happens if we have acceleration. And since we dropped it, we know we do. Okay? So we're going to have 10 is equal to v final plus 0. Our initial velocity was 0 divided by 2. We're going to multiply both sides by 2. And we're going to get an answer of 20 meters per second. And that's going to be our v final. Our v final. Okay, now you guys, this is going to be really typical. This is going to be really typical of our quiz because if you notice here, there was 3 questions. So in the quiz, there might be the same situation on 3 different questions, but then I'm asking you different things. So when you are doing this at home, set this up and you're going to find another question that is dealing with the same setup. And so you might find this to be helpful. So if you start on number 1 and you get a question like this, and then you come back to number 3 and you're dropping a rock again, go back to that and it can help you and set all those things up. All right. So, hey, you guys, I hope this helps and good luck with that quiz.